Good day. In this video, we are going to work on some examples on algebraic word problems. These types of problems, as the name suggests, involve algebraic equations, usually in single variable, that can be formulated by translating words into mathematical expressions. So here's problem number 1. John is 3 years older than Jim. Jim is 4 years less than twice David's age. How old are the three boys if their ages add up to 35? Okay, so let's use the given required solution format. To start, let us define some unknown quantities or unknown values. Notice that John's age is described relative to Jim's age, and in turn, Jim's age is described relative to David's age. So we can start by defining David's age. Let's say it's equivalent to X, and then we can work from David's age to Jim's age, and then lastly to John's age. Okay, so according to the problem, Jim is 4 years less than twice David's age. So you just multiply David's age by 2 and then subtract 4 to get Jim's age, and then from Jim's age you add 3 to get John's age. So we can simplify John's age as 2x minus 1, right? So we are asked to find the ages of the three boys. So these are the equivalent expressions of their ages. Solution. To solve for the variable x, you have to set up an equation based on the condition given, based on the constraint that their ages must add up to 35. So let's add their ages, x plus 2x minus 4 plus 2x minus 4 plus 3, and this must be equal to 35. Okay, so combine like terms, then isolate x. X plus 2x, that's 3x, plus 2x, we have 5x, and then negative 4 plus negative 4, that's negative 8, plus 3, so minus 5 equal to 35. Transpose negative 5, so we get 5x equal to 35 plus 5, that would be 40, and then divide both sides by 5, so 40 divided by 5 is 8. This is now David's age. To get Jim's age, so this is the equivalent expression for Jim's age. 2 times x, where x is 8, then subtract 4. So Jim's age is equivalent to 2 times 8, that's 16, minus 4. So that would be 12. Then John's age, again we can simplify this one as 2x minus 1. So 2x minus 1 equal to 2 times 8 minus 1. Therefore John's age is 16 minus 1, that would be 15. Next problem. Find 3 consecutive integers such that the sum of the first and the third increased by 3 is 50 more than the second. So let's start by defining the first of the 3 consecutive integers. Let's say it's equivalent to x. If the first integer is x, therefore the second integer is x plus 1, and of course the third integer is x plus 2. We are asked to find the values of the 3 integers, so that would be x, x plus 1, and x plus 2. To solve for x, you have to set up an equation based on the given conditions. Okay, so the sum of the first and the third, the first integer is x, and then add the third integer, so that's x plus 2. Increased by 3, so you add 3. is 50 more than the second? It means this expression is equivalent to the second expression, x plus 1, plus 50. Okay, then combine like terms, solve for x. So we have 2x here, plus 2 plus 3, that's 5, equal to x plus 51. Okay, so combine the variable terms and the constant terms. 2x minus x, that would be x. 51 minus 5, so that's 46. This is now the first integer. Okay, the second integer, you just add 1. Therefore, the second integer is 47. And then lastly, the third integer. So we have x plus 2, 46 plus 2, x plus 2 equal to 48. So these are the values of the three consecutive integers. We can also start by defining the third integer first. Let's say the third integer is x. If the third integer is x, therefore the second integer is 1 less than x. So that would be x minus 1. Second integer. And then the first integer, of course, is x minus 2. So, so to solve for x, we set up the same equation based on the conditions. The sum of the first and the third. The first in this case is x minus 2. The third is x. Then increased by 3, so add 3. And it's equivalent to 50 more than the second. The second in this case is x minus 1. Then you add 50. Okay, so combine like terms. 2x, 3 minus 2, that would be 1. Then we have x plus 49. Okay, 2x minus x, we have x here. 49 minus 1, that would be 48. This is now the value of the third integer, which is the same as the one that we obtained earlier in the first solution, right? Second integer, subtract 1. So x minus 1, or the second integer, is 47. And then lastly, the first integer is x minus 2. So 48 minus 2, therefore it's equivalent to 46. Next problem. If the lesser of the two consecutive odd integers is doubled, the result is 7 more than the greater of the two integers. Find the two integers. So we have two unknowns, okay, two consecutive odd integers. We can define the first, or the lesser of the two integers, as x. Therefore, the greater of the two odd integers is x plus 2. Okay, so we are asked to find the values of the two consecutive odd integers. To solve for x, let's set up the equation based on the conditions given. If the lesser of the two consecutive odd integers, this is talking about x, is doubled, meaning multiply by 2, the result is 7, so it's equivalent to 7 more than the greater of the two integers. The greater of the two integers is x plus 2. Then you add 7, right? Okay, so combine like terms. 2x minus x, we get x, that's 7 plus 2, that's 9. Therefore, This is the lesser of the two odd integers. And then the greater is x plus 2, which is 9 plus 2. So x plus 2 equal to 11. Next problem. Maria scores 96, 86, and 78 on her first three tests, respectively. What must her average score on the next two tests be in order for her to have an overall average score equal to 85? So let's define the average score on the next two tests as, say, x. Therefore, the sum of the next two tests is 2x. Okay, and then we have here the rest of the given first three scores, 96, 86, and 78. We are asked to find x, which is the average of the next two tests. So solution. To find x, we have to set up the equation for the overall average score. So we're dealing with an average number. It's equivalent to the sum of all the scores divided by the number of tests, right? So we have 96 plus 86 plus 78 plus her scores on the next two tests, which has a sum of 2x, then divided by the number of tests. So 1, 2, 3, 4, 5, 5 tests equal to 85. Okay, and then let's solve for x. We can cross multiply 5 or multiply both sides by 5, then combine all the constant terms. 96 plus 86 plus 78, that's 260 plus 2x equal to 85 times 5. So 2x equal to 85 times 5, that's 425 minus 260, that's 165. Then divide both sides by 2. So 165 divided by 2, we get 82.5. This must be Maria's average score on the next two tests to get an overall average score of 85. Next problem. In 2002, there were 301 long-distance area codes in the United States, an increase of 250% over the number when the area code plan originated in 1947. The question is, how many area codes were there in 1947? So let's define the initial number of area codes in 1947. Let's say it's equal to x. There was an increase of 250% over that initial number. So 2.5x, this is the increase in the number of area codes from 1947 to 2002. And then we have the total number of area codes in 2002, that's 301. We are asked to find x, which is the number of area codes initially in 1947. So let's set up the equation. In 1947, the number of area codes is x, and then in 2002, there was an increase of 250%. So add 2.5x because this is the increase, okay, from 1947 to 2002, which results to a total number of 301 long distance area codes. Okay, so this will now become 3.5x equal to 301. Divide both sides by 3.5. we get x equal to 86. So this is now the initial number of area codes in 1947. Next problem. If the perimeter of a rectangle is 18 inches and one side is 3 inches longer than the other, how long are the sides? Let's start by defining the shorter side or the width as x. And since the longer side is 3 inches longer than the other or the shorter side, so that would be x plus 3. That's our length. And then perimeter is equal to 18 inches. We are asked to find the measure of the sides, okay, width and the length. So let's set up the equation to solve for the measure of the sides. So we'll use the formula for the perimeter of a rectangle. It's just the sum of the measure of all the sides. So we have twice the length plus twice the width, okay, where the perimeter is equal to 18 inches, then the length is x plus 3, and then the width is just x, okay. So let's solve for x. This will become 2x plus 6 plus 2x, okay. Combine like terms, we have 18 minus 6, that would be 12. 2x plus 2x is 4x. Divide both sides by 4, so we get x equal to 3, and the unit is inches. This is now the width of the rectangle. To find the length, so this is the equivalent expression of the length, x plus 3. So 3 plus 3. Therefore, the length is equal to 6 inches. Next problem. The length of a rectangle is 3 inches more than its width. If the length were decreased by 2 inches and the width were increased by 1 inch, the perimeter of the resulting rectangle would be 24 inches. Find the dimensions of the original rectangle. So let's define first the dimensions of the original rectangle. Let's say the width is x, and then the length is x plus 3, because according to the problem, the length is 3 inches more than its width for the original rectangle. And then we have the new rectangle. The length is decreased by 2 inches. So initially we have x plus 3 for the original length, then we subtract 2. And then the width is increased by 1 inch. So initially we have x, so we add 1 to get the new width. And then the resulting perimeter is 24 inches. Okay, we are asked to find the dimensions of the original rectangle, which is x and x plus 3. Okay, let's set up the equation. Let's solve in terms of the new rectangle because we have the perimeter of the new rectangle. So that would be twice the length of the new rectangle plus twice the width of the new rectangle. Okay, so the perimeter of the resulting or the new rectangle is 24 inches. So plug in 24 equal to 2 times the length of the new rectangle. So x plus 3 minus 2, we can simplify this one as x plus 1 plus twice the width of the new rectangle. And the width of the new rectangle is also x plus 1, right? So 24 equal to distribute, so we have 2x plus 2 plus 2x plus 2. So 24 is equal to 4x plus 4 Transpose positive 4 to the left side, you get 20 equal to 4x. Therefore, x is equal to 5 inches. This is now the width of the original rectangle. And then the original length is just 3 more than the width. So x plus 3 equal to 8 inches. This is the original length of the rectangle. Next problem. Jeff can bike from home to his workplace in 3/4 hours. When he takes the bus, the trip takes 1/4 hours. If the bus travels 20 miles per hour faster than Jeff rides his bike, how far is it to his workplace? Let's begin by defining his speed. If he rides his bike, let's call that x. And then if he takes the bus, the speed is 20 miles per hour faster, or that's 20 more than x, so x plus 20. And then let's define also the distance from his home to his workplace. Let's call that d. Then we have the time if he uses his bike and if he takes the bus. Then we are asked to find d, which is the distance from his home to his workplace. So let's solve. Okay, regardless if he takes the bus or he rides his bike, the distance is the same. So we can equate the distance if he rides his bike and the distance if he takes the bus. Okay, then we'll be using the formula for speed, that's distance over time. If we isolate distance d, we get s times, or the speed times time. So this is equivalent to the speed if he uses his bike and the time if he uses his bike. And then for this one, the speed if he takes the bus and the time if he takes the bus. Okay, and then plug in the equivalent expressions and values. So speed using the bike, that's x, and then time if he uses the bike, that's 3/4. Okay, and then the speed if he uses the bus, that's x plus 20, and then time if he takes the bus, it's 1/4. Okay, we can multiply both sides by 4, so we can eliminate the fraction. So we get 3x equal to x plus 20. 3x minus x, we get 2x equal to 20. Divide both sides by 2, so we get 10 miles per hour. This is his speed if he rides his bike. The problem is the distance. So we can plug in this value to the distance formula. So distance equal to the speed times time. Okay, so x is his speed using the bike, so 10, and then let's use the time if he rides his bike, so 3/4. Therefore the distance is equal to 7.5 miles.